So without wasting any time, let us quickly start with our chapter. But before that, let me tell you something about Swiflearn. That what is Swiflearn all about? Okay, so Swiflearn, it is one of India's most sincere learning destination wherein you are having the classes from 1st to 10th. Okay, so how is it sincere? Let's see. We are having 100% live interactive classes here with personalized attention to each and every student with maximum 6 students in every batch. There is also an academic mentor team which will look after you throughout the session to track on your progress and to guide you throughout your session. We cover your syllabus as per your school time so that you don't face any problem in your school exams as well. Okay, then our key features. So what are our key features? First one is detailed progress report. How detailed? So here we will be giving you the whole progress, whole details of each and every chapter that you are attempting in your test, so that you can understand particular chapter you are very good at, particular chapter you have to work a bit hard. You also have Swiflearn Academic Test Series wherein you can compete with numerous students of your age and you can see for your position and you can work upon. Next, you can take unlimited practice test and also subjective test for your school exams so that you can practice answer writing perfectly. Okay, so let us move towards our chapter, but before that I would request all of you to kindly subscribe to this channel and press the bell icon so that you don't miss on any update. Okay, so our chapter today says physical quantities and measurements. We are going to see what are physical quantities and what is measurement important for us. So the objectives of this class or the things that we are going to cover in this class will include measurement and introduction. Then we are going to see for some physical quantities. We are going to see what is standard international units, which is also known as SI unit, and we are going to see the conventions of SI unit. Okay, so let us start. If I say over here that Rohit is taller than Soham, so how you will know that? By comparing them. And for comparing, what you have to do is you have to measure their heights. Yes, so here in the picture measurement is coming. What is measurement? It's a comparison of unknown quantity with a known or a fixed quantity of same kind. Okay, so for example, if I say, let's say this is 1 centimeter. Okay, so I need to measure one quantity which is of this length. So what I will be doing, I will put in our scale here which says centimeter scale and I will measure it. So what I am doing, I am comparing this unknown quantity with the known quantity. Okay, and this one is fixed quantity. So how we can define measurement? It is comparison of unknown quantity with a known quantity of same kind. Same kind means meter with meter, kilometer with kilometer, liter with liter, and so on. Okay, so let us understand this. Meter is universally accepted unit of length. So if we have to measure a length, we will be using meter scale. Okay, it is very obvious that we cannot be using liter to measure length. So meter, it is universally accepted unit of length. A length of 5 meter is just 5 times above the unit. So see over here, if let's say this is 1 meter. Okay, now what I have to do, I have to measure 5 meter. So 5 meter will be 5 times this particular length. Yes or no? So this will be 5 into 1 meter. It will become 5 meter. Okay, so what we are doing, we are comparing an unknown quantity with a known quantity of the same kind. So what does a measurement require? A measurement requires first of all a universal unit. So what is meant by universal? We'll just see shortly. And a number n which says how many times the unit is contained in the given quantity. So if I say 5 meter, so that is 5 times into 1 meter. So the number n here will be 5, which says that this particular thing, it is 5 times of 1 meter. Okay, so this is 5 and it is the unit. Okay, now if I say 5 meter, if I say 11 meter, this 5, this 11, these are the magnitude. What is the magnitude? The numeral quantity, it is known as magnitude. Alright, so the value obtained by measuring a quantity on the scale, it is called the magnitude. Okay, the numeral quantity, it is known as magnitude. But if I say the tea is too sweet today, can you measure the sweetness of tea in, let's say, any of the units? No. We can only say the tea is very sweet, the tea is less sweet, or like that. We cannot say the tea is 5 grams sweet or the tea is 2 grams sweet, anything like that, right? So we can just measure it like very sweet or less sweet. Now let's see what are physical quantities. So physical quantities are the quantities which can be measured. Like if I say 1 liter, 1 meter, these are the quantities which we can measure and hence they are known as physical quantities. Let us see some of the physical quantities. That is length, we have mass, temperature and time. So these are the 4 basic quantities which are known as physical quantities. Okay? Alright. So there are these 3 different types. Okay, what happened in the past time, there was no standardization. Okay, what happened, different countries, they were using their own units. Okay, like for example, there was one CGS unit. Okay, what happened in CGS, length was measured in centimeter, mass was measured in gram, and time was measured in second. In the FPS system, the length was measured in foot, mass was measured in pound, and time was measured in second. And then we had MKS system, in which we were measuring length in meter, the mass in kilogram, and time in second. So these were the different units which were used in different countries. Okay, and there was nothing same. Every country was using their own set of units. Okay, so what happened, because of this, it took a lot of time to convert them according to a particular country's set of unit. Okay, so then we needed a standard system of units which was accepted universally. Okay, so that we don't have to go through lot of process of converting them to this and that. Okay, so therefore a new system was introduced, and that system was known as SI unit. It is also known as Standard International Units. So SI, as the name says, it is known as Standard International Unit. Standard means it is same throughout the world. Okay, wherever you go, the length of meter will be same. Wherever you go, the volume of 1 liter, it will be same. It won't be changed. Okay, so this SI unit system, it is internationally accepted set of units, and it is having some basic physical quantities. This SI set of unit, it was implemented in 1960. So according to SI system of unit, the length, it is measured in meter. So the basic unit or the SI unit of length, it is meter. The mass we measure in kilogram, time is measured in second, and the temperature, it is measured in Kelvin. Okay, so these SI units, they are accepted universally, whether we are in India, whether we are in Africa, whether we are in USA, these all will remain same throughout the world. And hence it is very easy, as we don't need to convert from meter to kilometer at certain places, right? Just because they are universally accepted. Now let's see, if a quantity is very big or very small, so what we have to do, we have to adjust according to that. Let's say if I am measuring a long length, so rather than using meter, I will be using kilometer, right? But if I have to measure a very small length, then I won't be using kilometer, I will be using a meter, centimeter. Okay, so when the quantity is very big or very small, what are we doing? We are using multiples or submultiples as prefix before the SI unit. So if I say milliliter or millimeter, so it is 10 raised to power minus 3 times the standard meter. If I say kilometer, it is 1000 times the standard meter. So we multiply and divide accordingly to what we need. Okay, so using prefixes, it simplifies the quantity measurement. So rather than taking this long length and measuring it in meter, I'll just measure it in kilometer, right? So either what I can do, I can measure it as 2000 meter, which is a great quantity. But I'll do, I'll just convert it into kilometer and it will become just 2 kilometer. So for simplification, we are converting it according to the length or any other unit that we need. Okay, so if we are measuring very small quantity, then we don't need to measure it in meter or kilometer, we can measure it in millimeter. Okay, so millimeter, it is 0.0001 or 10 raised to power minus 3 meter. Okay, so what is the advantage of this? It simplifies our measurements. Now there are certain rules of SI units which we need to follow whenever we are writing. Okay, so symbol for unit, the first one is, the symbol for unit are always written in small letters except for the name of the scientist. So if we are using kilogram, we are writing it as kg, and you can notice that K and G both are small lettered word over here, not capital K and G. Then we are having meter, so we will be writing small m instead of capital M, and similarly for second. So what are we doing? We are writing the symbol of unit in small letters. Then some units, they are named after the scientist. Okay, so whenever we are writing them in the words, we also write them in small letters. Like if I talk about unit of force, it is named after the great scientist Newton. So we won't be writing N capital here, we will write small n and Newton. Okay, so even if they are named after scientists, if we are writing the full word, okay, then we will just write the small letters, not the capital letters. Third one, the symbol of unit named after scientist, it is always written in capital letters. So what's the difference over here? See, if I am writing Newton, 5 Newton. So if I am writing full Newton, it will be like this. But if I am just writing N, it will be capital. Okay, so if I am just writing the symbol, it will be in capitals. But if I am writing my whole word Newton, it will be in small letters. Okay, similarly Fahrenheit, ampere and Kelvin. Next, unit and symbol are never written in plural. So whether it is 1 kilogram or it is 1000 kilogram, we will always write kg, not kgs or meters or liters. We will always write and in the singular form. In words, the unit is written in small letters. So if we don't want to write just as M, if I am writing 10 meter, so I will just write it like this, no capital. Okay, it was same in the scientist names also, like 10 Newton. Okay, but if I am writing the symbol, it will be 10 N. Next, the space is left between the symbol of two units when they are used as product. So if I write the Newton, it is measured as Newton second, it is N and S. So this is symbol of Newton and this is symbol of second. So what I'll be doing, I'll be keeping a bit of space. I cannot write NS like this, it will be wrong. Okay, having said that, negative powers are used for compound units formed by dividing one unit by another. So if I say speed, okay, how do we measure speed? It is distance upon time. Okay, now let's see how do we measure distance. We measure distance, the SI unit is meter, and of time it is second. So for speed we can write either meter per second, or if the second goes up, the power will be negative. So meter second inverse. Okay, this is how we will be writing the speed formula. Okay, so what are the basic physical quantities that we learned today? It is temperature. We learnt about mass, which is measured in gram. Then we learnt about distance, and then we learned about time. So these are the basic physical quantities. And what is the SI unit of temperature? The SI unit of temperature is Kelvin, and mass, it is kilogram. Okay, now let us see the correct representation of units. Okay, so these are the 5 options which are given to us, and we have to select the correct one. So let's take the first one. It is showing 11 meters. So here it is meters, which is absolutely wrong. We cannot be writing them into plural forms. Next one is 15 kilometer. So it is correct. It is absolutely right, because K is also small here and we are writing full word. So that is correct. 2 kg. Here it is not correct. Why? Because here K is capital. So if you want to write, it will be like 2 kg. So this is also wrong. 3 ampere is absolutely correct. Why? Because ampere is named after a scientist, and therefore we are writing A capital. And last one, 7 Newton, is wrong. Why? Why is it wrong? Because N is again capital here, and we cannot be writing Newton like this. If we have to write, we will write either 7 Newton like this or 7N, just N. So then there is a value based question which says Rahul and Sonia were playing with blocks and each of them made a train out of them. Both of them thought of measuring the length of the train using their handspan. So what is handspan? This is this particular length. It is known as handspan. By that time, Rahul's friend Anupam came and suggested them to measure with the measuring tape for fair result. Okay, so let us see first of all what is handspan. And so the distance between tip of the thumb, like this particular thing, and tip of little finger, this is known as handspan. Okay, we are stretching our hand to full and then we are measuring the handspan. Okay, now let's take about second question, which will give the result also, that which will give the answer also, that why do we shift to standard units. So why Anupam asked both of them to use measuring tape to get accurate result, which is not possible with the handspan. What will happen? Like for example, see, if I take my hand, I stretch it fully, I measure from this point to this point. It is very obvious that everyone's handspan, the size will be different, and therefore we will be measuring different lengths. Okay, so for a uniformity, it is very important that we switch on to standard units. And the value of Anupam, which is shown here, is he is intelligent boy, he is an active boy. Okay, so rather than using handspan and non-reliable units, we can switch on for the reliable and standard units. Okay, so I'm sure you must all have once heard about this Julius Caesar. Okay, so there is a calendar which is known as Julian calendar. It was proposed by Julius Caesar, and it was based on the rotation of Earth around the sun. Okay, so he introduced 2 months in the calendar, which are July and August. So July, it was named after him, like his name was Julian. Okay, so it was named as July, and August, it was named after his successor Augustus. And the means of measuring time on the earth are not metric. Why are they not metric? Because our earth, it revolves around sun in 365.25 days. Okay, we cannot convert it into multiple of 10. Okay, hello Drishti, how are you? Yeah, so we cannot convert it into multiple of 10, so that is why it is not metric. Okay, and after 4 years we are also having these leap years, in which we convert these 0.25 days to one whole day, which adds on to 29th of February. Okay, then the question asks, which institution in the world maintain the guideline for using SI units correctly? So there is a institution which names as General Conference for Weights and Measurements. So this is the institution which maintains the standardization of SI units, and it makes sure that we are using all the SI units correctly. Using correctly means the length of 1 meter in India will be the same length which is used as 1 meter in rest of the world. There is no cheating, there is no fake thing which is going on. Okay, 1 liter, 1 deciliter, 1 liter, 1 kilometer, it will all be same throughout the world. Okay, so since we are done with the chapter, let's see the chapter and exercise and see what we have learned. So dash is universally accepted unit of length, so it is meter. Next, symbol of unit are always written in capital letter? No, not always. The international system of unit is commonly referred to as SI units. And okay, it's done. So what did we learn today? We learned about measurement, why is it necessary, and then we learned about various physical quantities. First of all, why did we need a standard system? So that there is a uniform measurement throughout the world. Then it was the standard international unit which was introduced in 1960s, which provided the same units of measurement throughout the world. And then we learned about some of the rules which we need to follow whenever we are writing the symbol of SI units. So I hope you might be clear with everything that we learned today, and we will be meeting tomorrow again with some new things about physical quantities and measurements. So till then, keep revising, keep learning, and take care. Thank you everyone.